The skeletal formula or the line bond formula is a way of reducing the bulky nature of the organic compounds. So, skeletal formula is just use of lines to represent all the details of the molecular formula of a compound. For instance, let us look at the structural formula presented before us. This is the formula of 6-ethyl, 5-methyl, 4-propyl, non-1,3-diol. 6-ethyl, 5-methyl, 4-propyl, non-1,3-diol. Non-1,3-diol. So, this particular structure is so bulky, therefore, you can use the skeletal formula to reduce the bulkiness. Using skeletal formula means you are going to use a point to represent each carbon atom and omit hydrogen. Then, a line to represent a bond joining each carbon atoms, and a carbon atom and any other atom that is not hydrogen. So let's start. This particular carbon is a point. The next carbon is going to be a point somewhere here. The next is another point. That is, we have represented 3 carbon atoms. And also, this carbon atom here with a bond here shows that there should be 3 more bonds because each carbon is tetravalent. Each carbon atom must have 4 bonds surrounding it, which means while looking at this skeletal formula, you assume that there are 3 other bonds joined to hydrogen that are not shown because in skeletal formula, hydrogen atoms are not displayed. So therefore, this point with a bond shows a methyl group, that is CH3. H, not shown. Then the second carbon with 2 bonds shows that there are 2 hidden bonds that are linked to hydrogen. That is why we have CH2 here. Then we continue. The next is CH2. The next is CH. Then on this CH we have an ethyl branch. So you branch it up 1, 2. Then you continue down CH, and there is another branch, methyl branch, just a line to a point. This is a methyl branch. Then we continue CH up to this point now, and we have a propyl branch. You branch it up this way, and this way. Then we continue to this CH with OH branch on it. You bring it down and write your OH. We continue CH2, that is this CH2, then CH2 again, and you branch again to OH. So you can see this is the skeletal formula. This is the skeletal formula for 6-ethyl, 5-methyl, 4-propyl, non-1,3-diol. This is another structural formula for a molecule. And the molecule is, we have ethyl branch here. We have ethyl branch here. Ethyl branch. And we have methyl branch. And we have OH, acanal branches, OH here and here. So counting from here, where the functional group is closer, we have 1, 2, 3, 4, 5, 6, 7. 4 ethyl now. So 4 ethyl, alphabetically E comes before M. 4 ethyl, 5, 6, 7. 7 methyl. 7 methyl. Then the longest chain contains 10 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is dec. Dec 1, 2. Second carbon has OH. 3, 4, 5. And fifth carbon has OH. That is 2,5-diol. So that is the molecule. 4-ethyl, 7-methyl, 2,5-diol. So we can use skeletal formula on this. The 10 carbon atoms are represented like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. On the second carbon we have OH. 1, 2, we have OH. On the fourth carbon we have ethyl. Second, third, fourth. Fourth, we have ethyl. 1, 2. On the fifth carbon we have OH. Fifth carbon, OH. On the seventh carbon we have methyl. Seventh carbon, methyl. And this is the simplified version of the formula called the skeletal formula. Okay, here is another formula. The longest carbon chain has 9 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is nonane structure. At the second carbon we have, this is CH3. Methyl. At the fifth carbon we have propyl. So we can easily represent this, but let me name it first. That is 2 M and P. M comes first, so 2-methyl, 5-propyl, nonane. 2-methyl, 5-propyl, nonane. So we can easily represent this structure by representing the 9 carbon atoms on the straight chain. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And the second carbon we have methyl. We represent methyl this way. 3, 4, 5. At the fifth carbon we have propyl. We have propyl. 1, 2, and 3. And this is the skeletal formula. Thank you very much for watching. Please, if you found this video valuable, share it, comment, and follow my YouTube channel. That is, subscribe to my YouTube channel, and make sure you follow all my Facebook handles and TikTok. Thank you very much.